All right, so in this video, we're going to be starting chapter 2. Chapter 2 is our graphing chapter, and section 2.1 is our intro to graphing. So all the time that we were in chapter 1, we were doing one variable equations. We were solving for x or whatever the variable was, but mainly solving for x. We solved quadratics and linears, other types of equations, but it was just one variable. So we were like a number line, solving for where it was at on the number line, the solution. Even in the inequalities, we had an interval on the number line, but it was always just the x-axis. So in chapter 2, we add in the y-axis, the vertical axis. And so just to remind you, when we point plot, we always do an ordered pair, the x value first and then the y. So for example, over 2 up 3 would be the point 2, 3. And we could plot a point like 3, 0. That would be on the axis, and so on. So on your handout, you'll see that there's 2 important formulas, and we're looking for how far are points from each other. For example, these 2 points, you know, if we wanted to know what is the distance between those, it's not a straight up and down or a sideways, so we can't just count the squares. It's a diagonal distance. So you could drop this straight down and then over, make it a right triangle, and then we could use the Pythagorean theorem. Side squared plus side squared equals hypotenuse squared to figure out that distance. Well, that's exactly what the distance formula does for us. So you'll see on your handout, the distance formula says subtract the x values, square it. Subtract the y values, square it. So that would be the distance this way. So subtracting the 2 x values tells you what that distance is. Then you square it. Then doing the y's the same way. See how far it went up and down, the difference in the y's. Square it. So a squared plus b squared will equal c squared. So to solve the equation, you would then square root to solve. So that's the distance formula. So that's how we find the distance between any 2 points in space. So we have an example here to try. Find the distance between the points -2, 3 and 1, 1. So please pause the video, plug that into this formula, and try that out. I'll also notice sometimes the formula says x1 minus x2. It doesn't matter. Some formulas, books listed as x1 minus x2. It doesn't really matter which order you subtract in. In this formula, it does not matter because you're going to square it. Whether we take, say we take -2 minus 1 or 1 minus -2, either way, we get either -3 or +3. That would be +3. That would gives us -3. But because the formula squares it, it doesn't matter which direction you subtract in. So either way you think about it, just subtract the x's, either direction, then square it, you're going to get 9. Same thing for the y's, either do 3 minus 1 or 1 minus 3, these 2 y values. 3 minus 1 is 2, 1 minus 3 is -2, so you see it does not matter because we're squaring that number. 2 squared is 4, -2 squared is still 4. So either way you subtract, on this particular formula, it does not matter because of the squaring. So for a final answer of the square root of 13. So that answer, the distance between this point and this point is a little less than 4. It'd be 3 point something. We could get a decimal approximation, but we usually leave it. That's the exact algebraic answer. All right. Let's also talk about the other formula, and then we'll do some practice problems. We have 2 big formulas in this section, 2.1. The other formula is the midpoint formula. The middle of a segment would be adding the x's and halving it. That would be the average between the x's. How far apart are they horizontally, comma, the average of the y values. So that is our midpoint formula. All right, so you have some U-tries. Again, always pause the video and do the active learning. The practice of this really does help you exercise these practice problems to learn them better. So we're going to do the distance formula and the midpoint formula. So for distance, we subtract the x's. -8, subtract 3, and then square that. Subtract the y's, 4 minus -2, and then square that. So that's -11 squared. That will be 6 squared. So 121 plus 36. And then we're going to square root it. So that is, what, 157. The square root of 157 is the distance. So that gives us our distance. We could get a decimal approximation, but that's the more exact answer. Okay, next we want to do its midpoint. So that's the distance from this point to that point. What's the middle of that segment, though, in space? You would use this formula, add the x's, -8 plus 3, and then half that, comma, add the y's, 4 plus -2, and half that. So that gives us a -5/2, comma, that will be 2/2 or 1. So that would be the middle point between these two on that segment. Okay, we're going to do that again. Another example. Number 2, our 2 points, -5, -6, and 7, -1. So let's find the distance between these 2 points. Again, you can subtract in either order. You can do 7 minus -5 or -5 minus 7. Either way, you get either -12 or +12, which we're going to square. And then -6 minus -1. Let me write that down. -6, subtract is in the formula, and then -1 will make that -5. Then the -5 gets squared, making it 25. So you got 144 and 25, which is 169. Don't forget, square root around that final answer. And so this one actually does reduce. If your radical reduces, you should reduce it if there's some way that you can do that. Our other example did not, but that's actually just 13. Did you know that? 13 times 13 is 169, so that one is a perfect square. So the distance between this point to this point is 13 units on the grid. All right, now let's do its midpoint between those 2 points. So that's the average of the x's, the average of the y's. So -5 plus 7, half that. -6 plus -1, half of that. So that gives us 2/2, which is 1. And -6 and -1 is -7/2. And we'll just leave it like that. -7/2, that would be the midpoint of that segment. All right, so those are the 2 big formulas that you do your homework. Then the other big concept is just the intro to graphing. Just general, what is graphing? So on the other side of your handout, I want to develop the idea of graphing. So like I said, you have 2 values now, an x and a y, that we're dealing with. Instead of just 1 variable, it's a 2 variable equation. So we're looking for combinations of x's and y's that add to be 7 in this case. What solves this equation? So they're combos. For example, 0 and 7. 0 for x, 7 for y. That would work. 1 and 6. 2 and 5. 3 and 4. You may just be able to rattle those off. You can't always just look at it and know what those are, but in this case, we can. Maybe also vice versa. 5 and 2. 6 and 1. 7 and 0. There would also be fractions like a half, 6 1/2, a fourth, 6 3/4. Lots of fractions, infinite fractions even. Negative numbers like -1 and 8, -2 and 9. You could do this forever and always. There would be a combination of x, y values, infinite ones that add to be 7. The neat thing about linear equations, and that's what this would be, x is to the first, y is to the first, is a linear equation, is all of its solutions will line up perfectly on an XY axis. So using graph paper or sketch a graph, plot some of those points and let's see what happens. Let's see, I didn't start over far enough here. I can do better. So I want to be able to go out 7, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, because I see one of my points is 0, 7, Then this point over 1 up 6, 2 and 5, over 2 up 5, over 3 up 4, over 4 is up 3, then 1, 2, 3, 4, 5, 6, 7, 0 and 7, or 7, 0 is there. -1 would be up 8. How about a fraction, like over a half, up 1, 2, 3, 4, 5, 6 and a half? Every point that solves that equation has to fall on this line. They have to line up perfectly. Now, if you take a straight edge, I'll do my best here. I didn't do great, but you can see they do line up. We fill that in with arrows to say, hey, not only are these some of the sample values, but it keeps on going infinitely in both directions. And even the little fractional amounts between it that I haven't designated here, there would be infinite points even between those points. So we fill this in solid to say everything that falls along this line graphs. This is the picture of the solutions, basically. There's infinite little points, more than we've even listed, that work to make x plus y equals 7. Linear equation. That's one way to graph, is by point plotting. Let me point out some critical points. This is considered the y-intercept. The y-intercept always occurs when x is 0, when you let x equal 0. So here we see 0 for x, 7 for y. That's how you find a y-intercept in general with graphing any equation, by plugging in x is 0. So 0 for x, solve for y, y is 7. This one is the x-intercept, and always in all graphing, the x-intercept occurs when y equals 0. So we can see right here, when y is 0, x is 7. And also you can see it intercepts or crosses the x-axis at that point. Those are intercepts, critical graphing points. Okay, well, what if the equation was something not so obvious? Say it was 2x plus 3y equals 6. Now, off the top of my mind, I just don't know all those combos. I can't just rattle those off. So it's not always as obvious. Or say it was 3x minus 7y equals 99 or something. I don't know those answers. I would have to do a little more work to figure those out. I couldn't just guess some things that work. 3 times something minus 7 times something that equals 99. You know, we probably don't know that. So we have strategies for finding that. We can do it by point plotting. We can plug in, like I said, 0 for x. We'll tell you the y-intercept. Sometimes you're asked to find that. So whenever x is 0, I can then just equation solve and figure that out. 2 times 0 is 0, so I just have 3y equals 6. Divide both sides by 3, and there it is. That's the y-intercept, 0, 2. I could also find the x-intercept by letting y equal 0. So if I plug in the y is 0, 2x plus 3 times y is 0, what makes that work? 3 times 0 is 0, so it's just 2x is 6. Divide both sides by 2, and x is 3. That's the x-intercept. Then we could find other points. I could plug in x is 1, x is 2, x is any number that you can imagine. There's infinite x, y values that solves this equation. So usually we ask you find a third one just if you're point plotting, because any 2 points would line up, you know, just connecting. But if you have a third one that also lines up, then you can probably feel a little more assured that you did not make a mistake on the other 2 points. So let's see what that would be. 2 times 1 is 2, plus 3y is 6. Throw the 2 across the line. Oh, this one doesn't come out as even, but it's still a valid point. It just might make it hard to graph. So I might shop for another point or try a different value. Again, that's a valid point, but it's just not as easy to sketch the graph of. And you've got infinite ones to choose from, so maybe plug in a different number. Let me do -3, for example. I could do -3 for x. 2 times -3 plus 3 times what is 6. That one solves out a little nicer. I kind of forethought that and thought that might. but you can guess and try different numbers because there's infinite ones to choose from, but that would be a good crisp point that is on that line. Again, there's infinite ones. These are some sample values. That is point plotting, kind of the base idea of one method for graphing. And we'll look at another method when we come back on the next video.